All right, folks, this is 3.3, understanding y-intercepts. All right, so our objective here is to find the y-intercept of a linear equation from a table or graph and interpret the meaning of y-intercept in context. Got a couple of vocabulary terms. Y-intercept and versus slope-intercept form. Y-intercept, of course, is where your line crosses the y-axis. Slope-intercept form is just the name of the equation that looks like this. Slope is the m, b is the y-intercept. It's called slope-intercept because it involves the slope and the y-intercept, slope-intercept. Okay, 8-year-old Alex is learning to ride a horse. The trainer says that a horse ages 5 years for every 2 human years. The horse is now 50 years old in human years. How can you determine the age of the horse in human years when Alex was born? So I'm just going to make a table. We know that Alex is 8 years old and the horse is 50. So I'm going to kind of like use that as the basis for my table here. So X, Y. X is human years, or X is Alex, and Y is the horse. Okay. Let's see, 8 versus 50. I'm just going to put it right here. Okay. We know that for every 2 human years that we go back, that we go back or forward, really, the horse is going to go 5 years, right? So let's see. Perfect. Okay. So as I go backwards, right, I know I'm going to be subtracting 2 here each time. Okay, to get to that 0, right? This is basically when Alex is born, is when the x value is 0, right? The horse is going 5 years for every 2, right? So 45, 40, 35, and then 30. So when Alex was born, the horse was 30 years old. The age of the horse. The horse is 30 when Alex is born. Horse is, or was, let's say 30 when Alex was born. Okay, I know there was some discussion in my accelerated block about that. I don't want to get into it. But anyway, moving on. Caden and the Queens are going bowling. Caden can rent shoes at the bowling alley or use her mother's vintage bowling shoes. How can she determine how much money she will save if she brings her mother's bowling shoes? Write the equation of the line in slope-intercept form. All right, so we got the prices right here. And we've got our graph right here. Graph is going up by 2 each time, right? 2, 4, 6, 8, 10, 12, 14. Is that right? 6, 8, 10, 12, 14, 16, 18. Okay, and these are going up by 1, actually, each time. 7, 8, 9, 10, 11. Okay, so for one game, it's $4. So I find number of games 1, and I go up to $4 right there. 3 games is 8, so 3 to 8 is right there. 5 is 12, right there, and then 10 games is 22, which I think is all the way at the very top, yeah. Okay. Now I'm going to extend my line to basically figure out the y-intercept here, and that y-intercept is going to be how much the shoes cost, basically, right? Okay, so we can see that the line is crossing right there at 0, 2, so our y-intercept is 2. So that's $2 for the shoes. How much money? How can she determine how much money she will save? She will save $2 if she brings her mom's shoes. Yeah. Okay. So this is really quite similar to what we just did, but I've already got the points graphed rather than having to graph the points. So we're just going to extend it here and see where it crosses the y-axis. There we go. Just like that. So we can see that it's at 4, right? You could say 4, you could say 0, 4, because that's where it crosses the y-axis. The equation is going to be in the form of y equals mx plus b. This is your slope-intercept form. That b is going to be that 4. Now we just need to figure out the slope. We just need to figure out the m for it, right? We go up 1, 2, 3, and over 2. 2. And you can honestly do that every time, right? Up 3 over 2, right? So it really doesn't matter where you start. So we can start here, go up here, go right, over 2, right? We could even extend the pattern down to figure out the y-intercept without drawing the line. Again, it's going to be rise over run. Let me write that down here. M is rise over run. I'll write it on the graph here. Rise for the 3, run for the 2. So our slope is 3/2. And when we write it into our equation, that's what we get right there. Okay, now, similar concept with the table, but we have a table instead of a graph, right? So it's a different representation. So if we extend our pattern backwards to get a 0 right here, we see we're going up by 2's each time, right? So if we extend it backward, basically just we subtract 2 to get to 0. So whenever you have an x value of 0, that number for the y is your y-intercept, right? We can see that 0, 4 right here. That's that same concept, right? So we're going up by 3's, it looks like here. So if we reverse it, we'd subtract 3 here, we would get 12, okay? So y-intercept is 12 because, now we can't say that's where the line crosses the y-axis because we don't have a graph, right? So we'll say that's where your x value is 0. Right, so we basically work with what we can prove, and we can prove that our x value is 0 here in the table. Now we've got our rise over our run, 3 over 2 for our slope. Okay, we know our b value is 12, so y equals mx plus b becomes y equals 3/2 x plus 12. Hey, Gabe. So our equation is right there. I mean, very similar things, even like slope is the same. Probably should have made it different, but what are you going to do? The same concept, though, just based on a graph versus a table. Right? We use the same thing here, but with like real-world context examples. Okay, so we're going to graph these 3 equations, A, B, and C. We can already see that they're slightly different in that this is proportional, which means it's going to go through 0, 0, so it starts at 0, 0. Okay, and then we're going to go up, down 1 and right 2. It's down because it's negative, but it's always right because otherwise it's not going to work out. And you'll have a mirror of the graph if you go left when you're supposed to go right. Okay, so this is y equals -1/2 x. And then we got -1/2 x plus 3. This is going to start at plus 1, 2, 3. And it's going to be the same thing. It's going to go down 1 and right 2. Okay, I extend my graph, right? I give as many points as I can because that makes our line straighter when we graph it. Okay. And then we start at -4, so down here we go down 1 and over 2, and then we can reverse it to get more. Instead of down 1 and right 2, we go up 1 and left 2, okay? And then go like so, and this is y equals -1/2 x plus 4, okay? Now hopefully we can see the difference here, right? That happens when we add that plus b, when we make it non-proportional, right? How are the 2 equations different? That y equals mx versus y equals mx plus b, and how do they affect the locations on the graph? So y equals mx starts at 0. Let's say goes through 0, 0, because it doesn't necessarily start there, because it's weird to say it starts there when, I mean, it goes infinitely in both directions. If it's like a real-world problem, then it makes more sense to say it starts at 0, 2, or 0, 30. But when it's just like a problem where there's no context and you're just doing the math for it, then you should probably say goes through 0, 0. Or the origin. While y equals mx plus b moves the line up with a positive y-intercept. Right, so we've got this plus 3. We basically take each point on the original and move it up 1, 2, 3, 1, 2, 3, 1, 2, 3, right? Or down with a negative y-intercept. Okay, so we've got this, that y equals negative 1/2 x minus 4. You shift it down 1, 2, 3, 4, and it's every point, right? This is basically when we took like triangles or squares or whatever and then translated them around with translations, reflections, rotations. This is just a translation of your graph up or down, okay? Yeah, anyway. Okay, you would call these lines parallel, right? They don't cross, they don't touch. Can two lines have the same y-intercept? What does that look like? Well, we start at 2, right? We're going to go down 3 and right 1. So 1, 2, 3. I'll give myself another one here. Okay, so that's y equals negative 3x plus 2. And then starting again at plus 2, and then we're going to go up 1 and then over 4. Reverse it there as well. Okay, that's y equals 1/4 x plus 2. Okay, so what does that look like? Well, they both start at the same point, or they both go through is also another way to say it, probably go through the same point, but have different slopes. Okay, all right. Yeah, I don't know, hopefully that makes sense. Some spiral math review. We're going to subtract 4, just solving this equation. 6x equals 24. You divide by 6 because that's the inverse of this multiplication that's happening right here. You get x is 4. X squared equals 4. We square root on both sides. If I have a square with an area of 16, let me bust out a poppet here. Right, yeah. If I have a square with an area of 16, right, we can see that these are the poppets that are up, right? We just want to find the side length. That's all square root is. So 1, 2, 3, 4 by 4 is 16. So the side length is just 4. So the square root of 16 is 4. Technically, it's also negative 4, okay, because negative 4 times negative 4 is also a positive 16. This, however, is just going to be a negative 4, right? Because if I say, oh, it's a positive 4, then 4 times 4 times 4 just gives us a positive 64. However, we need a negative 64. So that's why it's not a positive 4. Whammo, there you go, guys. Hope you enjoyed.